For the next example, same idea. We have these test scores, and you can make this you can make this histogram. You can make it using Google Sheets. For time consideration, I'm not going to do that. But, I do recommend that you actually try and make it. Again, this data you would have to list in a column. And then, you would click on histogram in Google Sheets. You can change the bucket size if you want, things like that. Okay? I do recommend you practice making these, so strongly recommend that. Are there any questions so far? Okay. Okay, so here's another example. Again, it's good to be able to read these, what the histograms are telling us. So let's say we have this histogram, and the situation is a group of adults, okay? They were asked how many children they have in their families. Okay, that's what they're asked here. And this is the histogram of the data. And again, notice that for each bar, okay, each bar represents a value on the x-axis. It's actually all values greater than or equal to 0, but strictly less than the right endpoint. Excuse me, all values greater than or equal to the left endpoint, strictly less than the right endpoint. So how many families have no children? That would be from this bar, which is 5. No children. How many families have one child? Okay. Well, in this case, you're going to have 3. Frequency, number of children. Okay. How many families out there have 3 children? 2. That's from here. And so on and so forth. I mean, maybe a histogram isn't the best for this example. For this kind of problem. But again, I'm just trying to get everyone to read a histogram. Okay. That's one example. Now, okay, so here is actually the same idea, but now we're going to ask this. How many adults were questioned here? In other words, how many adults were actually questioned in this survey or whatever it is? Well, you can actually get that from the histogram. You basically would just add up the frequencies. You're going to add up the frequencies. You can guarantee that's going to give you the number of adults. You're not going to count someone twice because someone can't have no children and one children, right? And one child, that's impossible. You can't have both. So you don't have to worry about double counting. So basically, you're just going to add up the frequencies. That's all you do. And if you did that, you would get 5, 3, 4, 2, and 1. And I think that's adds up to 20. No, excuse me, 15. That's what it adds up to. Okay. Again, you just add up the frequencies. So we know how many there are. Now we can answer the next 2 questions. Let me just stay on this slide, I guess. How many, what percentage had no children? Well, notice from the histogram, the number of adults that said they had no children was 5, right? That's from this bar, 5. Okay, 5. Okay, so we have 5 out of 15. How do you get the percent? Well, again, you just divide and then multiply by 100. 5 out of 15 times 100, that's about 33.33%. Now, how many had one child, right? Well, again, we would have to look in here. Not here, here, because the left endpoint we include. So we have 3 out of 15. So 3 adults said they had one child. Okay, so what's 3 out of 15 times 100? Well, that's 0.2 times 100, which is 20%. All right, that's good. Okay. Well, let's do another example. Then I'm going to move on to chapter 11. There we go. So here's another histogram. Again, we really can't make the histogram. We don't have the data. Okay, but let's say a group of students took an exam and the scores were presented here. Okay, well, how do we know how many students took the exam? Well, again, it's just like the previous question. How many adults were questioned, right? How many data values would you have? Again, it's the same as asking that, so you just add up the frequencies. That's all. Add up the frequencies. Okay, so in this case, you would have 2 plus 2, 1, 2, 1, 2, 2, and you keep doing that. That's how you would do it. You would add up the frequencies. And then from there, you could figure out what percentage of students got a 70 or above. How would you answer that question? Well, for that percentage, well, how would you get the number of students who got a 70 or above? Well, you just add up the frequencies, right? For 70, you would have this one, right? And higher, you have these. So you just add them up. Add up the frequencies, that is. Okay, so how many students took the exam? Well, again, you're just adding up the frequencies. So it turns out you get 20. What about 70 and above? Well, again, you're only going to add the frequencies here associated with these bars because you want 70 and above. So here you would have one person got between a 70 and less than 75. Here's another person who got at least 70, right? They got between 85 and less than 90, and so on. You have 1, 2, 3, 4, 5. Well, 5 out of 20 is, 5 out of 20 times 100 is 25%. You just divide and convert it to a percent by multiplying. That's all. Do you have any questions about this? Okay. All right, well, let me move on to chapter 11 then. Let me just save this. Let me get chapter 11. Here it comes. So here, what we're going to look at is describing data. That's what we're going to do first. We're going to describe data. First, we're going to describe what a distribution is, okay? Then we'll see what's called measures of central tendency. You'll see those are actually ways of deciding what we mean by the middle or center of a data set. When I say data set, I mean data values you obtain. Like, for instance, scores on an exam, that could be a data set. Or, when we said before, if we were to ask every college student in SUNY Oneonta how many hours a week they read, the answers we get would be a data set, things like that. You can also measure the variation, how much the data varies, how much variation there is. Then we have this notion of quartiles, and then we'll see box plots. Box plots are nice because, well, what's nice about them is we'll be able to make them easily using Desmos. So that's what's really good about that. Thanks to Desmos, we don't have to draw it by hand. So that's good. So again, this is what we'll do in chapter 11. All right, basically you can have what's called distribution, and this is what we mean by distribution of a variable. It's just all the possible values of it and the frequency each possible value could take on. People study distributions of variables because what can happen is many times a data set, like for instance, body weight of a group of people, IQ, or test scores, for instance, those data sets tend to fit a distribution of certain variables. So instead of having to study each data set from scratch, you can actually you can see if the data set fits. That is, if it looks like the distribution of a certain variable. And if it does, then you would see then you would consider the properties of that distribution of the variable. Like what the average is, how much variation it has, things like that. I mean, hopefully it'll make more sense as we go on in this chapter and the next one. But basically, instead of studying each data set individually, you can determine if a data set fits. That is, if the data values, if the layout and stuff looks like the distribution of a variable. And then instead of studying that data set from scratch, you can just learn about the distribution of that variable, its layout, what properties it has, stuff like that. It turns out, actually, we'll see this later on, lots of data sets fit what's called the normal distribution, of a normal variable. We'll see that later. That's actually in the next chapter. Okay, to actually show a variable's distribution, you can look at the frequency tables of the data set and or histograms, because they show you the layout of the data set. Sometimes also, if you want, you could actually show a distribution, which one it has, by drawing a smooth curve. I know the book does more of that. Sometimes you may have a formula that gives you the distribution. Excuse me, you can use a formula. The formula will tell you the possible data values. What's nice about a histogram is you also get the frequency as well. Because remember, it's not just values, it's also frequency. Okay, something like a smooth curve you can imagine drawing on a histogram. Something like this would be one example. Well, you might have a variable whose distribution of whose range of values looks like this. Here we have numbers between 0 and 1, and the frequency is also given. Although here we would need a histogram for that. But a distribution, there's many different shapes a distribution can have. One is actually called symmetric.